This meeting is being recorded.
For problem 5 from chapter 19, it may be a good idea to reference some of the tables given in chapter 19. So I wanted to point out here table 19.1, where we see some aldehyde preparations that have been covered in previous chapters. So oxidation of primary alcohols, ozonolysis of alkenes, the hydroboration, oxidation of terminal alkynes. These all produce aldehydes. Then we're going to be referencing some ketone preparation also in this problem. So we have oxidation of secondary alcohols, and this is all in table 19.2 now. Then we have ozonolysis of alkenes again, different alkenes. And then we have acid catalyzed hydration of terminal alkynes. And then finally, the Friedel-Crafts acylation we saw in just in chapter 18. So all of these previous methods have been used to accomplish these transformations shown in problem 19.5, parts A through F. So let's take a look here. In our first transformation, we go from a secondary alcohol, so we can write that down here, secondary alcohol, and we produce a ketone. So as we just saw, oxidation of a secondary alcohol to give a ketone, this can be achieved with chromic acid. So we have chromic acid, which we know we would mix our sodium dichromate with sulfuric, right? So we have aqueous sulfuric as well. So we could list these reagents here. And if we were to write them kind of in a reaction sequence here, we could list them like this. Okay, let's take a look at transformation B. Now we have a primary alcohol, and that's going to be transformed into an aldehyde. So we can also oxidize a primary alcohol, just like we did before with the secondary alcohol, but this time we'll achieve an aldehyde. And we could use either PCC, right? So we can list PCC. We could also, actually, let's list some various options. We could do PCC in dichloromethane, or we could do the Des-Martin, DMP, with dichloromethane, or even a third option, which would be a two-step. We could use dimethyl sulfoxide, DMSO, and the other reagents involved in this transformation, and triethylamine here. So this is abbreviated like so. Any of these one or two-step processes could be used for this transformation. All right, now we have in part C, we have a terminal alkyne, right? So we'll write down what we have. So we could go back to our reference table and see that we're going to achieve a ketone here into specifically a methyl ketone by doing the acid catalyzed hydration in the presence of mercuric sulfate. So we have H2SO4, our acid, in water, and then that mercuric sulfate. So again, this can produce a methyl ketone from a terminal alkyne using these reagents. So something similar here, we have a terminal alkyne. If we want to convert this to an aldehyde now from a terminal alkyne, we can use some different reagents. We can do a hydroboration oxidation. And if you recall, with alkynes, they have this generalized formula used for the reagents. And we have to have our hydrogen peroxide in basic conditions as well. All right, so now we have E, and this transformation is accomplished through ozonolysis, and we can do this using ozone and dimethyl sulfide as our reducing agent. So this would be a two-step process to go from this cyclic methylcyclopentene to this dione shown here. Last, in part F, we can install this acyl group using a Friedel-Crafts acylation, and this would be an acceptable halide that we could use, shown here. And of course, we would just need aluminum chloride as well.